Hello friends, this is Suresh and we are going to discuss about VZZ, best practice toward VZZ, its architectures, so on. So today contents and we are go through what is VGG and what is the VGG block or architectures and which kind of the use cases we can leverage VGG for especially detection and classification. So VGG is 16 and I'm taking VGG 16 and another name also VGG 19 we heard about. So first I'm taking it VGG 16. So VGG 16 is a convolutional neural network architecture. It's same VGG 16 come from act as a it has 16 layer. Its layer consists of the convolution layer, max pooling layer, activation layer, fully connected layer, and so on like softmax like that. You heard about the ImageNet classification challenge, ImageNet's large-scale visual recognition challenge, and which is come in the picture that time. It participated in 2014 ILSVR competitions, and it was runner. It was a runner-up. Yeah, we can say runner-up winner of ILSVRC 2014 competitions. And the dataset they use ImageNet classification in ImageNet dataset, heard about it. This competition gives out of 1,000 classes of training set and 1.2 million images and validation set of 1,000 of images and test set of 150,000 of images. So using that images, which he performed very well he received second position at that time of competitions. Before going to VGG, I'll just brief about the journey of this ILS VRC competitions. The x-axis showing year and y-axis showing error. So in 2010, the classification detection error into 28%, then is decreased by changing the algorithm, decreased by 25%, then 16%, then 11%, then 7.3% in 2014 LSVRC competition. And same time the election also GoogleNet also getting 6.7 error. And the first winner was GoogleNet, but second winner was VGG. So what is the difference between these networks? So we can say VGG was a successor of AlexNet. We can say. So before discussion VGG, I'm just brief about AlexNet. So what is AlexNet here in AlexNet architecture? Just for example, this is a flow of the AlexNet architecture. This is convolution layer, then max pooling, then convolution, then max pooling, then convolution, then max pooling, then convolution, so on, and network going on. And they are performing that accuracy 16.4 like that. Using similar kind of the structure and similar kind of theory, one group of like we can say the visual group of geometry, visual geometry group of Stanford University, they find some best solution using creating the visual block. So that block they call VGG blocks. So before that they are in one by one they are using they creating the series of the layer, convolutional layer, max pooling layer, convolution layer, max pooling like that. But here they are changing the structure of the network in the grouping. For example, in particular group they are using two CNN layer. For one layer, these are two CNN layer, then they are using max pooling layer. So with this max pooling, this is called one VGG block. Then another this two CNN and then max pooling, then 3 CNN, then max pooling, then series 3, then max pooling, and so on. And they are finally so on. They can use fully connected layer, whatever. But the theory behind it, for extraction, good feature map, they creating continuously two convolution layer and then max pooling layer. And for what they are changing here, they changing here especially like filter size also. Somehow in the previous election, somehow they are using somewhere they 5x5 filter also, but here they are using 3x3 filter and some padding padding according to what, for example, this convolution layer 1 output should be the same as the input. So according to they are using the padding and stripe. So this is called visual block. We can say VGG block. So this is called VGG block. Another theory of VGG block I'm telling, for example, this is the input and this con 1, con 1 1 and con 1 2. 1 means here first convolution, first layer, first convolution, first layer, second convolution, then pooling. Then second layer, first convolution, second layer, second convolution, then pooling. Then third layer, third convolution, sorry, not layer, I have to take here block. Third block, second convolution, third block, third convolution, then pooling. So on fourth block, fourth convolution, fourth block, second convolution, fourth block, third convolution, then pooling, and so on. Then they getting the bench. And using this VGG block, you can go more deeper and get better results. So other customized VGG net also, you heard of VGG 19 also, they adding one VGG block also. You can add more VGG block and you can create your custom networks. So similar, this picture shows whole the VGG block and how downsampling the image and finally flatten. We are getting 1000 class here. So here for example 120 into 112 into 112 size of image. For example, image is input 124 and 124. One drawback I am telling you ki as an input we are as an input of VGG, the fixed size of image 124 and 124. So you have to pre-process your whatever data set you have in particular size, then you have to feed to the network, and then convolution happen, and then this pooling layer, the size 124 will be half using the pooling layer. Then again in other VGG block, then pooling layer, then size will be half. Then another VGG block, then pooling layer, size will be again 28, then 14 half, then so on, then flatten layer, and then softmax, and then they are getting the results. So this is whole architecture of the VGG net. And next I'm discussing about where we can use a VGG network. So generally the main purpose of VGG net was is especially designed for the competition of ILS VRC, but you can use in many way with your customizations. So just like you can use for classification purpose, like you want to image classification, different kind of classification. For example, this is dog image, this is cat image, this is goat image, like that, and detection also. And you can leverage that also. And basically, for example, in ImageNet dataset 1.2 million of images there, then you can use that pre-trained ImageNet model, and you can fine tune and you can do transfer learning for special your cases. For example, you want to detect some car, bike, person, vehicle, like that, then you can use VGG pre-trained network and then fine tune with your data. Then you can get better result also. And some example I'm taking the facial recognition also. Another like these weight also already available for other framework, for Keras, for Pythos, for like that. So you can directly use for that. And another style in VGG 19 they are adding, then also you can also leverage. So these theory about the VGG net and where we can use VGG net and these things. So thank you so much watching this video. Please subscribe the channel for next upcoming video. Thank you.